Is it possible to turn this back into this? That's the question the Center for Rainforest Studies is trying to answer by replanting a cinder cone with Mabi rainforest in the Atherton Tablelands. But first, what is a cinder cone, and what is a Mabi rainforest?
A cinder cone is a geologic formation created by a volcanic vent, essentially a steep hill with acidic, nutrient-rich soil. Mabi forest is a critically endangered rainforest type existing only in the wet tropics. It's named for its most popular resident, the tree kangaroo, or Mabi, and is home to many endangered plants and animals. Mabi rainforests used to be found on many cinder cones. However, due to clearing for agriculture, less than 4% of Mabi forest remains today.
In 2024, the center began replanting a cinder cone located between Wongaville State Park and the Curtin Fig National Park. The center aims to test reforestation techniques, such as companion plants, while working on improving the connectivity of Mabi habitat in the tablelands. This is the first time an organization has tried to restore Mabi rainforest on a cinder cone, probably because it isn't easy. Our seedlings are planted on the western slope of the cinder cone, which gets more wind and sun than the other sides. The steep slope, intense sunlight, and invasive grasses are challenges to native seedlings as well as students.
We want to produce a type of manual, best practice restoration of Mabi forest on cinder cone. So most Mabi restoration projects, they focus on even or flat areas. Nobody has actually attempted to restore such a steep slope. This has challenges, for instance, extreme dry conditions, very strong water runoff. So these things we want to actually check out. Another big question is which species we should actually select.
We wanted to find out which species of Mabi plants are most effective for establishing forest cover on such a challenging site. Keep in mind, Mabi seedlings usually grow within an established Mabi forest, where the soil is rich in nutrients, the temperature is lower, and layers of leaf litter protect them from weeds. Here we asked them to grow in full sunlight and dry conditions. We surveyed trees from other cinder cones to find out what kind of Mabi vegetation grows on them. We collected and ID'd a total of 38 Mabi species, which grow successfully on the western slope and could be planted in future experiments.
Acronychia acidula, Codium variegatum, Ficus copiosa, and Melia azideric are some of the species we found most often.
We began by measuring seedling heights to assess how well our plants are doing. We had two different plots, one from 2024, testing whether bananas as companion plants can improve seedling growth, and one from 2025, testing bleeding hearts as companion plants.
We thought that companion plants would help seedlings become established by providing shade and limiting the spread of weeds.
Instead, we found that overall, companion plants tend to compete with the seedlings instead of helping. Growth rates were significantly lower in the plots with bananas and significantly higher in the control plots in the 2024 planting.
Castanospora in the 2024 planting did very poorly, exhibiting high rates of mortality.
I also would like to emphasize climate change, the heat waves we have. We are right in the middle of one. These species we find in these successional Mabi forests, they probably are able to handle heat. And we have to basically modify the Mabi species composition a little bit to have a suitable species suit for a Mabi restoration on the cinder cone. It's almost like talking a little bit about a novel ecosystem under the climate change conditions we are facing at the moment.
We hope that our work will help inform other researchers attempting to replant Mabi forests, so this rare ecosystem and its species won't disappear.